Now that you've got a little bit of experience with exponential functions, let's actually look at analyzing them a little bit more in detail. So what is an exponential function? What you're going to notice here, it has to be some sort of y equals 2, but now you've got some base to the power of x. That's the important thing. That has to be an exponent, making it, guess what? An exponential function. Hooray! And you know and I know the graphs are going to look something like this or something like this, depending on things. Well, what does it mean? Well, let's look at the graph that looks actually like this. And you have to remember a few things about this. You have to remember that the a value has to be bigger than 1, okay? The other thing that you have to remember is that this actually has a y-intercept equaling to 1. Okay, it has a horizontal asymptote here of equaling to 0. It also means that the domain here can be anything it wants, any number you want, and the range here has to be, y has to be greater than 0. It cannot be equal to 0 because, of course, of this horizontal asymptote. Now, the other difference here is, remember, when a now is between 0 and 1, which means that it is a fraction. So this means that it's going to look something like this now. So fractional form. So think about the same things. The y-intercept is still equal to 1. You still have a horizontal asymptote that's equal to 0. And you have a domain which is still belongs to R, and you have a range here where y still has to be greater than 0 and not equal to, again, because of this horizontal asymptote. Well, that's really nice when they look nice in what I call really pretty looking exponential functions that look like this. But what happens now if we play around with this function a little bit? What happens if the function doesn't look pretty anymore? Well, guess what? Remember this? Do you remember what all of those things meant? Do you remember that this a value told you that it's going to be a vertical compression or expansion? You remember that the b value meant horizontal, right? Same thing as before. Remember the h and k moves, this moves left and right. This one moves up and down. And of course, we said that because we're in Math 30, we like to write it with the k over on this side. Well, whatever. It doesn't matter, okay? But it's interesting to see that this same idea now can be applied to, guess what? Exponential functions. Take a look at this. This is so cool. There's that same stupid k value, just like before, just like it was right here. So this tells you that you're going to move up and down. So you're going to take that whole thing, that whole graph, and move it up and down. But now they have an a value. Well, they don't like using a. They like using, guess what? So what? They've changed the letter to c. Who cares? But you know that that c still means that you're going to make a vertical expansion or stretch or compression. It's either going to get taller or shorter. Look at this one. Now, instead of using a b, they use, guess what? They use a d value. Oh, whoopee-doo. So what? It's a d. The d now becomes your horizontal. And guess what is really cool about this? What's really, really cool in this horizontal is, guess what? Yup, it's flipped. Oops, it's flipped. There it is. So as a matter of fact, that's going to flip. That's going to give you your horizontal expansion and contraction. And look at this. The h is still the same. That guy is the same as this, telling you can move left or right. So I got a great question for you right here, and let's do this one together. It says, use the graph of y equals 2 to the x to sketch this guy right here. Okay, so we're going to get some stretches and a few other things, but you know what I'm going to do first? I want to understand what this graph is first. I want to see what it looks like first. So I'm going to boot up my calculator here, and I'll just move it over a little bit. Okay, so I'm going to punch in y equals to 2x here. So y equals to 2 to the power of x. And I'm going to graph it again. This is still the same function that I dealt with last time. You see that it goes through the 0, 1, and everything else. But I want a table of values here. So let's go to the table of values and play around with this table of values. And the table of values I want to deal with is I want to go from -2 all the way up to 2. So here we go. Looking at the table of values, I'm going to go from -2 to 0.5 here. I'm just going to basically cut this section of it out right here. Okay, that's all I'm going to do. So let's plot those numbers down. So -2 and 0.25. I'm going to go -1 and 0.5. Then I'm going to go 0 and 1. 1 and 2 and 2 and 4. Those are on my regular graph right here. Now let's start doing some cool things. Let's start identifying who is who. So I'm going to take my eraser, get rid of this marking, and let's get this under our belts and see what we're actually going to make. Well, what is the D value? Well, remember, the D value has to come here. Well, wait a second. Hold on. There's a problem here. I always had a bracket around this like this, but there's no bracket here. So this is how I'm going to catch you. So be very, very careful. This minus x plus 2, you have to have a bracket right here, but the bracket is missing. So in other words, in order to have a bracket there, you have to factor that negative out of both things. Watch again. Let me show you what I mean here. Okay? Currently, I have a -x plus 2. I'm going to factor a negative out of this one and this one to give me a negative up front and an x minus 2. Now, that starts to look an awful lot like our equation. So, what I've got here is I've got 3 times 2 to the power of -x minus 2. What does this mean? Well, my D value then is a -1. So my D value is a -1. So this is x over -1, which means I'm going to have a horizontal reflection across the y-axis. This is -2, which means, okay, if that's -2, that's got to be +2, right? There's my new coordinate based on this equation, okay? Let's look at the C. The C is here, is 3. Why? There is no k here. There's no value of plus k here. K actually is gone, so it's a 0. So my y-coordinate is just that. It's the toughest part is figuring out what's this formula. And it's very easy to figure out once you get this formula in proper form. So again, this would be your C. There's your vertical component. There's your D. There's your horizontal, which is going to be a flip. And there is your H, which is going to be moving 2 units to the right. And that's why this is a plus, not a minus. So what happens to our coordinates? Real simple. Let's take this x, plunk it into that formula, and see what happens. So we have -2 over -1 plus 2. Well, what does that become? -2 over -1 is 2, plus 2 is 4. So that new coordinate is actually 4, comma. Here's 0.25, put that in here. 3 times 0.25 is easy to figure out. It's 0.75. So there's your new transformed coordinate. Let's look at this guy, -1. Put the -1 where the x is right there. -1 over -1 is +1 plus 2. Your new coordinate is 3. And all I'm doing is using this formula here. Okay? This is 0.5. 0.5 times 3 looks like 1.5 to me. All right, take the 0. 0 over -1 is easy. That's going to be 0 plus 2, so we've got a 2. Simple enough. 1, put into here now. 3 times 1 is 3. You've got a new coordinate of 2, 3. Let's use this one. 1 over -1 is -1 plus 2 is now 1. Take the 2, put it in here. 3 times 2 is 6. And then finally, here we go. 2 over -1 is -2 plus 2. This coordinate is 0. And 4 times 3, which is 12. There's your new coordinates. They're all transformed nicely according to this graph. So let's actually plot this out and let's see what it looks like. All right, here we go. So first thing I would do is, okay, let's start with the 4. 1, 2, 3, 4, and 0.75 looks like it's probably around there or so. Okay, the next point is 3, 1.5, so 1.5 is about there. Okay, the next point is 2, 3. 2, 3 is about here. The next point is 1, 6. 1, 6, 3, 4, 5, 6 is about there. And the last one is 0, 12, 6, 7, 8, 9, 10, 11, 12, which is about here. And this is what your graph is basically going to look like. Something like that. Okay? Now, if you want to prove that looks like that, let's pull up our calculator. Okay, clear the ink on this. And watch this, because it's really, really cool. Remember all of these values? Let's see what it looks like. Go to your y equals 2, get rid of your original graph just by hitting enter, and that'll clear that. Oops, let's go up to the equal sign here, sorry. Hit enter, that clears that graph, but it's still in your memory, so if you want to refer to it, you can. Go back over here now and put the new graph in, which is 3, now bracket it, 2 to the power of, now put all of that stuff that was here, all of this stuff that was here in the bracket by itself. Okay, so let's see. 2 to the power of, bracket, negative x plus 2, close the bracket, and don't forget, we still have one more bracket to deal with there. And now let's graph it, and hopefully it looks very, very much like what I just drew. And look at that. It's identical. And if you want to see, watch this. Go second and hit the table, and let's see what all the tables are. Here we go. We were at 4, so let's mouse this down to 4. There it is. 4 is exactly what we had, 0.75. So that tells you right away that the formula that you created using all of those transformations is working perfectly. 3 is 1.5, 2 is 3, 1 is 6, 0 is 12. So every single one of these, this formula here is 1000% accurate, and that's how you do these problems.